All right, welcome back, class. So this video is from section 7.6, and we're going to talk about the objective of using the Pythagorean theorem. So what is the Pythagorean theorem? Well, it's a method for determining the length of sides of a triangle. If A and B are the legs of the triangle, which you know they are because they're the legs that are connected to the right angle here, then C is the hypotenuse. Not sure how to spell that. C is the hypotenuse. So, and this C is the side that is opposite of the right angle. So if this is a right triangle, then the Pythagorean theorem says that a squared plus b squared equals c squared. So you could have just a triangle question, something like, hey, if there's a triangle, a right triangle, and these are the lengths of the sides, then find B. So it could be something as simple as you're just given a triangle and you are supposed to find the length of the missing side. So in this case, again, B is what we're looking for. So I'm going to plug everything I know into this Pythagorean theorem. So 4 would be A. So we've got a squared plus b squared is going to be equal to c squared, which is 10. So 4 squared is 16, plus b squared is going to be equal to 100. We're trying to isolate b and find the length of b. So again, we're finding the length of this unknown side, which is b here. So I'm going to subtract 16 from both sides, and I get that b squared is equal to 84. If I want to know what b is, then I can take the square root of both sides, and that means that b would be equal to the square root of 84. Well, 84 will factor, we can list factor pairs here. We've got 2 and 42. That's not helpful because this isn't a perfect square. We've got 4 and 21. That is the most helpful because 4 is a perfect square and 21 factors to 3 times 7, which can't be factored down further. So this is going to be the same thing as the square root of 4 times 21. And we're going to take out the 4. So we've got two square roots of 21. Of course, you could approximate this value in your calculator, but on the test it'll be given as an exact value. Again, this is the exact value of the length of this side that we don't know. This kind of seems weird because typically we don't have a good idea of, well, okay, so has anybody ever heard of the measurement of 2 square roots of 21? Like, does some certain distance pop into your mind? Probably not. So let's look at this again real quick. So we got 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Well, 21, the square root here, is somewhere between here. So we're looking at the number between 4 and 5. So the value of the square root of 21 is somewhere between 4 and 5. Okay, so let's just say it's 4 times 2. So this is going to be somewhere between 8 and 10 meters. Okay, for an approximation. Again, that's just to kind of give yourself an idea of what this measurement actually means. Let's do another one where we are missing C instead of a leg. This triangle looks like this, with this being the right angle. This is 5 square roots 3, and this is 10 centimeters. And we want to know what C is. Again, C is always the side that is opposite of the right angle. So in this case, A and B are interchangeable because in addition, the order doesn't matter. So it doesn't matter if I plug this side in as A or this side in as A, it's not going to make a difference. So I'm just going to use 5 square roots of 3, make that squared, plus 10 squared, and that's going to be equal to C squared. Well, 5 square roots of 3 squared means that I have this. I have 5 square roots of 3 multiplied by 5 square roots of 3. I have it twice. 5 times 5 is 25, and the square root of 3 times the square root of 3 is the square root of 9, which is just 3. When this comes out, it's related through multiplication, so I get 75, and of course 10 times 10 is 100, so 75 plus 100 is going to give me a 175. That's what's equal to c squared. I don't want to know what c squared is, though. I want to know what c is. So to find c, I'm going to need to take the square root of both sides. And I want to break this down. We've got 7 25s inside of here. So this breaks down to 25 times 7, and that will simplify to c is equal to 5 root 7. This is a perfect square. It's going to come out and be 5, and the 7 stays under. So this is the length, and it is centimeters. Again, what does 5 root 7 mean? Well, 7 is in between 2 squared and 3 squared, somewhere in the middle. So, you know, this is somewhere between 2 and 3, so this is going to be between 10 and 15. All right, the last type of a problem that I want to do is an actual story problem from this section using the Pythagorean Theorem. I have seen one of these on the final before, but not often. So this problem says that if you are let's read this problem. So there's a 50-foot supporting wire that's being attached to a 75-foot antenna. Because of surrounding buildings and sidewalks, the roadways, the wire must be anchored exactly 20 feet from the base of the antenna. So let's go through that again and say we have this antenna here that is, the length here is 75 feet. And again, there's a supporting wire attached to it, but the wire has to be 20 feet away because of buildings and other things. So it's anchored exactly 20 feet from the base of the antenna. So from right here. So here's our right angle. And this wire is 50 feet. So this is our supporting wire. So here's our picture of the problem. Again, real quick, I'll read the problem one more time. 50-foot supporting wire is being attached to a 75-foot antenna. Because of surrounding buildings and sidewalks and roadways, the wire must be anchored 20 feet from the base. So question here is two parts. The first one is, how high from the base is the antenna? So basically find the length of this distance right here. Which is a leg because it's attached to the right angle. Again, it's an A or a B, not a C. The 50 foot is a C. So we want to know how far up the wire it is. So with that, we're going to say A squared, we'll just do 20. And this would be A, this would be B, and this would be C. Plus the X squared is going to be equal to the 50 squared. So 20 squared is going to be 400. Plus X squared is going to be equal to 2500. 50 times 50, or 5 times 5 is 25 with 2 zeros, so I'm going to subtract the 400. And we will get that X squared is equal to 2100. Again, I'm looking for this length of X, so I'm going to say X is equal to, and this is going to be 21 and 100, and the square root of 100 is 10, so this is going to be 10 root 21. And so the length of this side, again, what does 10 root 21 mean? Well, 21 is between the square root of 4 and the square root of 5, so this is between 40 and 50 feet. If local regulations require that a supporting wire attached at a height of no less it has to be attached at a height of no less than 3/5 of this 75 feet, or 3/5 of the length of the antenna. So 3/5, this is a part B of this question, so it needs to be 3/5 of the 75 feet height. This 5 will go into this 75 15 times. So this wire has to be at least 45 feet high to meet regulation. Okay, well, is it 45 feet high? So to calculate that, we would have to calculate the value of the 10 root 21, which is approximately equal to, if you put it in your calculator, do 21 square root, and it'll give you something between 4 and 5, and then you times it by 10, and we get 45.8 feet. 45.8 rounded to the nearest tenth. So it has to be at least 45. So the question is, does the length, or does this meet regulation? And because this is 45.8 is greater, the actual length, or that it is fastened up here, is greater than regulation, then it does meet regulation. So that is the Pythagorean theorem, and hope y'all are doing well.